So this is a review lesson. It's Algebra 1, Semester 1, and it's a unit called Inequalities, number 2. And it's a lesson number 7, Absolute Value Inequalities. It's on CreatorMathcom under the Algebra 1 tab. You might have to Google CreatorMath.weebly.com to find the site. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from CreatorMath.com. So before we get to that, I always try to help students find out where those notes are. It's a little bit hard to find. Let me see if I can pull that up. So here's the name of the website. It's creatormath.weebly.com. Type that into Google. You should be able to find this homepage right here. Once you find this, anything you need to know about the composition book, because a lot of students don't understand the composition book, even to this day, scroll down until you see the words composition book. Please read all the directions, please watch all the videos, please follow the due dates, and follow all the instructions on where things go. If you do, including the notes, you should have a 90 to 100% in that part of the course, which is the composition book notes, which back you up for the problem sets, which we do right here. So for this video, this is the proper tab we're clicking. Under this tab are the video lessons, are the vocabulary lists. There is a vocabulary study PDF. It's a complete list of vocabulary for the entire semester. It is downloadable to your device and it is searchable. Just Google, how do I search a PDF with whatever type of device you have. It is different for different devices. Now I'm going to scroll to the semester for which this video applies. This is the table of contents. You should have already written this entire table of contents onto pages 2 through 6 of your composition book. If you haven't already, please stop this video and go back and do that now. Follow the videos on the prior page we just showed. It'll tell you how to number the pages. It'll show you examples of great comp books and give you instructions on how to fill out your comp book. So now we're going to find the unit we're in. This unit is Inequalities right here. There are 1, 2, 3, 4, 5, 6, 7 lessons. We're in this lesson right here, number 7, Absolute Value Inequalities. Here are the page numbers upon which these notes should be written. The notes we'll click into right now and show those. The problem set is what we're working on now. And then the video solutions will be linked up here once this is done. It'll be to this video that we're doing right now. So opening notes that go on the right pages of your comp book sometimes takes me a couple times, but you'll see it clear up. Sometimes it can be done in one. You're going to copy these problems into your comp book on the correct pages. You'll notice certain instructions like flip both signs or flip two signs in this case when we're solving absolute value inequalities. Can be a little bit complicated, but not too bad. It's basically equation solving with a few twists. Then we'll be graphing the results in 3 different ways, or illustrating the results in 3 different ways. We'll be doing an inequality format where we show the x's between different values. We'll be doing a set notation and we'll be graphing it on a number line. All right, so as we go down through here, we'll show these. There are vocabulary that needs to be written into your comp book and basic things that will help you understand when you get to the problem sets. So with that said, let's go ahead with this problem set. These problem sets often start with just basics for warm-up. Given this symbol like this, what is it called? It's a greater than, you guys. Greater than, the larger side would be on the left. The smaller side on the right is greater than. If you reverse it, this is known as less than. From left to right, the smaller side comes first, less than. If we understand those two symbols, we might also then understand that if it's this way, greater than or equal to, and if it's this way, less than or equal to, right? All basic understandings that most students know by now, but sometimes a little bit of review just helps to warm our brain up. On a number line, what does the open dot mean? So say we've got a number line, we have a 0, we have a, let's say it's 1 and it's an open dot. The open dot means the value of 1 is not included, it is excluded. Excluded means not to include. Okay, so say it was everything below this 1, it does not include 1. It would be 0.999999999x, etc. But it would not be 1. 1 is not included. We would need a solid dot for that, which is what the next question asks us. On a number line, what does a solid dot mean? So say it's that same situation. Here's 0 and here's 1. And now all of a sudden it's a solid dot. It's filled in and it's going off to the left. This includes the 1 value. So it would be x is less than or equal to 1 to show this thing going all the way to the left forever. All right, so the value is included with a solid dot. Given a parentheses in set notation, what does it mean? So a parentheses mean the number or value is excluded, just like an open dot. A bracket means the value is included, just like a solid dot. So we'll show set notation, and you're on lesson number, what lesson is this? This is lesson number 7. We've been going over this for 7 lessons. If you've been doing those in order, I'm hoping this is not new for you, but review, and therefore we're going a little bit quicker. Given a plus infinity, how is it read? It's read positive infinity. Positive infinity is on the right, goes to the right on a number line, a horizontal number line. What is a negative infinity? It's pronounced negative infinity, and it goes to the left on a horizontal number line. If we were using a vertical number line, positive infinity would be up and negative infinity would be down, right? So it depends what you're talking about, but the idea of negative infinity is it's forever increasing in a negative fashion. The numbers are getting increasingly large in a negative manner, forever. Okay, so that leads us to the next question. Is infinity a number? The answer is no. Infinity is a concept that numbers either increase or decrease in the form of negative infinity forever. Right? So is negative a billion negative infinity? No. It's just a number on the way to negative infinity. So there is no single number that can represent infinity. It's not a number. It's a concept. Right? So therefore it cannot be included. You couldn't put a solid dot on a negative infinity, for example, because we don't know what that number ever would be. All right, let's get in the actual problem. So this is an absolute value symbol, and we've gone over these two, so this isn't new. We've covered absolute value. This is an absolute value inequality. We're going to solve this 2 ways. We're going to take x minus 5 is less than 3, just like you see it here, but remove the absolute value. Then we're going to solve it a second way where we say x minus 5 is greater than a negative 3. What did we do? We flipped 2 signs. We flipped the actual inequality in the opposite direction, and we flipped the value of this one to a negative 3. Why? Because the absolute value could be a negative value, and in this case we don't know, so we can solve this both ways to see what 2 values we get. So we're going to add 5 to both sides right here. And we're going to get x is less than 8. Okay, and then we're going to add 5 to this one. And we're going to get x is greater than 5 minus 3 is 2. So x is 2 things. It's less than 8 and greater than 2. The way we write this is we put the x in the middle. It is greater than 2, so the 2 goes on the left, and it is less than 8, so it looks like this right here. X is sandwiched between 2 and 8, like 2 pieces of bread, and x is the meat in the middle of the sandwich. Okay, so this is x. 2 is less than x, which is less than 8. This is true. Now we want to put it in set notation. Neither the 2 nor the 8 are included because they're less than and less than. It would have to have an equals to include them. So we're going to use a parentheses, 2, comma, 8 parentheses. Right? Some students want to confuse this with a coordinate point. It is not a coordinate point. It is a completely separate topic called set notation. Notation. All right, one more way. Let's put it on the number line to show. So let's say this is 0, this is 2, and this is 8. Because they're parentheses and because there's no equals, these have to be open dots. They do not include 2 and 8. But everything in between them is included, an infinite set of values in between 2 and 8, excluding 2 and 8, open dot, no equals here, and parentheses to show that 3 different ways. So 2 comma 8 with parentheses around them, this is what we got here. All right, let's go to the next. Let's solve the same way. 4x minus 6 is less than or equal to 6. We're going to do it another way too because the absolute value is less than, we're going to flip it, greater than or equal to negative 6. Add 6 to both sides. 4x is less than or equal to 12. That's one answer. Please hold. Divided by 4. Divided by 4. X is less than or equal to 3. There we go. And let's see what we get here. Add 6 to both sides. This becomes 0 over here, and this becomes 0. You get 4x is greater than or equal to 0 divided by 4 divided by 4. X is greater than or equal to 0. So two values. The x is in between, the x is less than 3, and the x is greater than or equal to 0. So we start out with a 0, and we say less than or equal to x, or x is greater than or equal to 0, and less than or equal to 3. Right? So it's sandwiched between 0 and 3, and it's got equals, so 0 and 3 are included. How do we list that in set notation? We say bracket 0, comma, bracket 3, because both the 0 and the 3 are included, therefore we need a bracket. So it's this one here. One more representation. Let's take some space here. Let's put a 0 and a 3 in. We are including the values, so we need a solid dot on the number line. And x is between there, sandwiched between. It's every value in between these two. So 3 different ways we're representing it. The equals show that the 0 and 3 are included. The brackets show the 0 and 3 are included. And the solid dots on the number line show that the values of 0 and 3 are included. All right, one more. 4x minus 2 is less than or equal to 14. We're going to also do 4x minus 2 is greater than or equal to, flip that sign and flip the positive 14 to negative 14. Add 2 to both sides. 4x is less than or equal to 16 divided by 4 divided by 4. X is less than or equal to 4. Add 2 to both sides. The negative 12, all right, is greater than or equal to, gone, 4x divided by 4 divided by 4. X is greater than or equal to negative 3. So it looks like we're going between negative 3, x is greater than negative 3, x is less than 4. So let's say negative 3 less than or equal to x less than or equal to 4. So the x is sandwiched between the negative 3 and the 4. Notice x is less than 4 is good, check. And x is greater than negative 3, we reversed it, but x is still greater than negative 3. So in terms of brackets, there's equals here, or set notation. We're going to use a bracket, negative 3, comma 4, and we're going to use brackets because equals means these two values are included. In terms of a number line, come on, there we go. In terms of a number line, we have a 0, we have a 4, we have a negative 3, and because they're bracketed, because they're equal, they must be solid dots. They are included in this range, or set, as we call it. And so it's all numbers in between these, including negative 3 and 4, which is an infinite number of numbers. So we're going to circle this one here to say the x is sandwiched between negative 3 and 4. It's got the equals in there, and we got the bracketed here, and we show a number line also. Okay. Please make sure to match up the title of the video with the problem set you're doing for it to make any sense at all. This is Algebra 1, Semester 1. It's a unit called Inequalities. It's the 7th lesson called Absolute Value Inequalities. It's on CreatorMathcom under the Algebra 1 tab. Hope this helps.